Okay. Okay. I need you guys to listen because I'm going to give you quite a bit of information right now for the rest of the week. It's very important. Hello. Okay. So, last week you did Unit 11 Day 1 notes. The PowerPoint is broken up into 4 lessons. And so the Day 1 notes were on the first 2. So today we are probably going to get through Lesson 3. Tomorrow we are going to get through Lesson 4. And then we are done with the PowerPoint. So on Friday, you will have a test on this unit. Before that, in order to give you as many grades as possible, because I understand there's not a lot of classwork for this unit, you will have mini quizzes. You will have 1 mini quiz for each lesson in the PowerPoint. So there are 4 lessons, so you have 4 mini quizzes. Since we've already done lesson 1 and 2, tomorrow you will get mini quizzes 1 and 2. So I suggest that you look over the main concepts of lesson 1 and 2. Your mini quizzes are only about 5 questions each. So I can't quiz you on the nitty gritty. Look at the major concepts of each of the lessons. So you'll get lesson 1 and lesson 2 mini quiz tomorrow. Wednesday you will get mini quiz number 3, which is on lesson number 3, which is what we're doing today. Thursday, you will get mini quiz number 4, which will be on lesson number 4, which is what we'll do tomorrow. And then Friday, we will have our test. I'm thinking also on Wednesday, we will do a lab in here where we will be making oobleck. If anyone's ever made oobleck. Okay. It's going to get very messy, so that's okay. That's what science is. So Wednesday, we'll do oobleck. Thursday, we will do our 4th mini quiz and test review, and then Friday will be your test. And then next week, when you get back from your 3-day weekend, we will do our next unit. Yes, sir?
So we will do the test review on Thursday?
Yes. So I am planning on having the PowerPoint done by tomorrow. So then Wednesday and Thursday, we'll do our lab, and then we'll do our test review, and then Friday will be our test. Okay?
That's gonna be hard.
I don't think so.
Freaking chemistry. She knows exactly. She knows it's like the back of her hand, so she doesn't.
Oh yeah. Oh yeah. Okay. So the mini quizzes though are going to be a good idea of how your test will be. Okay. And it should all be easy because it's solids, liquids, and gases. You're looking at the comparison between the 3 states of matter. So hopefully it's all easy. Okay. So that's what's happening for the rest of the week. So tomorrow you're getting mini quizzes 1 and 2. Wednesday you're getting mini quiz number 3. Thursday you're getting mini quiz number 4, and then Friday is your test. Okay? Yes. I think I'm gonna do them like any other quiz. Well, they'll be in class or online. I think what I'll do is I'll make all 4 of them open until Friday. So like if you're not here for one of them, then you can just take that one online by Friday. Okay. All right. So you are going to do number 3 in your notebook today, which is Unit 11 Day 2 notes. So that is going to be the rest of the PowerPoint. So we're going to do lesson 3 today, which is liquids and solids. And then lesson 4 we'll get to tomorrow. Yes, I do. So come get one. Here, I'll get you one. I only have 2 left, so, or 3, I have 3 left. So,
I still have to give the last because we had a sub and
okay.
So should I come in like tomorrow morning or during lunch?
Do what?
Take the finish.
Yes. Yeah, whenever
Tomorrow during lunch.
Whenever. Yes, that's fine. Alright. So this is Unit 11, Day 2 notes. This is number 3 and number 4. So quick recap, listen, recap from last week. So we started talking about gases, so now we need to talk about liquids and solids. We were talking about the unique behaviors of gases because of the thing that's called the kinetic molecular theory. So the kinetic molecular theory makes a few assumptions, mostly about gases, but we can use those assumptions to tell us why liquids and solids behave the way that they behave. This is what we're going to talk about today. So your kinetic molecular theory says that your particles of your gas are very, very small, and there's a lot of space in between those particles, and so they have certain properties. Also, we talked about the what temperature is. So remember, temperature is not how hot or how cold something is. Temperature is the average kinetic energy of the substance that you are taking the temperature of, okay? So your particles, each of those has a different kinetic energy because each of those particles is going to be moving at a different velocity, so they're going to have a different kinetic energy. So the average of all those particles' kinetic energies is the temperature of that substance. So that is your kinetic molecular theory. That is why gases behave the way they do. And then we introduced our intermolecular forces. So we have 3 types of intermolecular forces, and they are what? Hydrogen bonds?
Covalent bonds.
No, intermolecular. Dipole, dipole, and dispersion. Which one of those 3 is your weakest bond? Dispersion is your weakest. Which one is your strongest? Hydrogen bonds. Very good. So that is what we talked about on Friday. So now we need to talk about the kinetic molecular theory and our intermolecular forces, because both of those things together are going to explain why solids and liquids behave the way that they do. So first, we need to define exactly what a liquid and a solid are. So a liquid is a state of matter with an indefinite shape but a definite volume, and a solid is a state of matter with a definite shape and a definite volume. So you have to know the difference between definite and indefinite. If something is definite, that means that you cannot change it. If something is indefinite, that means you can change it. But what we're talking about is if you just put the state of matter into a different container. So if you have a liquid and you put it into a different container, can you change its shape and its volume? You can change the shape of its you can change its shape, so that's why that one is indefinite, because you can change it just by putting it into a different container. But what you cannot change just by putting it into a different container is its volume. No matter what container you have a liquid water, specifically water, no matter what container you have it in, you will always have the same volume. The only time that you won't is if you add stuff to it or take stuff out of it. But we're not talking about that. We're talking about if I have this bottle of Gatorade, this has a definite amount of volume. Okay? If I put this Gatorade into a different container, it could have a different shape because the shape of the container could be different, but it will still have the same amount or the same volume of Gatorade in it. So liquids have an indefinite shape, but no matter what shape you make it into, it will always have the same volume. Again, unless you take it out or add stuff in, but that's not what we're talking about. We're just talking about moving it from one container to the other. If you have a solid and you try to put it in a different container, you're not going to change the shape of it, and you're not going to change the mass of it, or the volume in this case. Because both of those things are definite. You cannot change them just by putting it in a different container. Okay? So with that logic, what I just said, what would a gas have? Shape and volume, what would they both be? They would both be indefinite, because you could change both of the shape and the volume of a gas. Why? Gases are what? How do you change the volume of a gas? Compress it or expand it. So that is why a gas has an indefinite shape and an indefinite volume. Because you can compress it and change the shape of it and put it in a different container. And also because you can compress it, you can change its volume. So gases have indefinite shape and volume. Liquids have indefinite shape but definite volume. And solids have definite shape and definite volume. So you have to think of you taking that substance and just putting it in a different container. How would you change that substance? How would you change its shape? And how would you change its volume? If you can change it easily, then it's indefinite. If you cannot change it easily, then it is definite. Okay? Okay. So now that we know what the technical terms for liquids and solids are, now let's start looking at the different characteristics. So we talked about, the first thing we talked about of gases was density, the density of gases, and its compressibility. So now let's talk about solids and liquids and its density and its compressibility. So we already said that solids are the most dense, right? And gases are the least dense, and liquids are somewhere in the middle, okay? So this is kind of reiterating that, but now we're adding in this aspect of temperature. So if we have a liquid and a solid, both at a liquid and a gas, both at 25 degrees Celsius, that liquid is still going to be denser than that gas. So liquids are always denser than gases. Solids are always denser than liquids. So it's just saying that no matter what temperature you have them at, it's always going to be the same thing. Because, and what we're going to look at next unit is it has to deal with the relationship between temperature, pressure, and volume. And that's what we'll look at next unit. So, don't worry about that right now. But remember, temperature is the measure of the average kinetic energy. Liquids are denser than solids. Solids are denser than liquids. Basically saying the same thing. So if something has the same temperature, if something is at the same temperature, then those two things have the same kinetic energy. Again, because temperature is the average kinetic energy. If they have the same temperature, then they have the same kinetic energy. Okay? So now we're wanting to know why are liquids more dense than gases, and why are solids more dense than liquids? Well, it has to deal with, or the explanation comes from, the kinetic molecular theory. That empty space in between your particles is getting smaller and smaller. So your particles are getting closer and closer together, which means that your intermolecular forces are going to get stronger and stronger as your particles get closer together. So your solids are your most dense because there is very little space in between the particles. Your intermolecular forces are keeping those particles very close to each other, and so they're going to be the most dense. They're going to have the most particles in one volume of that thing. Your liquids have a little bit more space in between your particles. Therefore, your intermolecular bonds are a little weaker, so then they are going to be a little less dense. You can't fit as much in one space as you did for your solid. And then taking that one step further back to gases, there is a lot of empty space. Your intermolecular bonds are very weak, so they're not going to be as dense. They're going to be even less dense. So solids are your most dense, liquids are in the middle, gases are your least dense. Okay? So when you are looking at stuff for your mini quizzes, again, your mini quizzes are very short. I cannot quiz you on the minute details. So look at your overall picture. Look at the vocabulary that we used in lesson 1. Look at the overall differences between the states of matter. So how do gases differ than liquids, differ than solids? Those are the kind of things that you're going to want to study for your mini quizzes. Okay? So don't focus more on the why. So the why is this happening, is because of the kinetic molecular theory. Don't focus on that. Focus on what is happening. What is the difference between these three states of matter? What are the vocabulary that you need to know that was in lesson 1? Because lesson 1 mini quiz is mostly vocabulary. Okay? Okay. Compression. So we said that gases are easily compressed and expanded. So what about liquids? Well, liquids, because they are a little bit more dense than gases, they're going to be harder to compress. There's going to be a lot of energy, a lot of force needed in order to compress those liquids because those intermolecular forces are stronger and because there's a lot less space in between your particles. So, gases are easily compressible. Liquids and solids are not easily compressible. The key word being easily. Okay? Easily compressible. Solids and liquids are not easily compressible. Gases are easily compressible. Why? Because your kinetic molecular theory. Blah, blah, blah. Okay. Two unique things of liquids and gases. Anyway, two things that you need to know of is the difference between fluidity and viscosity. So if something is fluid, then usually it is a liquid. So we should all understand that liquids are fluid. Okay? So if you spill water on the floor, it's going to flow across the room. Now, it's going to stop eventually because those intermolecular forces are going to keep those particles somewhat close to each other. But if you have a lot of water spilt on the floor, then it's going to go pretty much everywhere. Okay? The opposite of that is viscosity. So viscosity is the resistance to flow. So if something has viscosity, if something is more viscous, then it's usually going to be a liquid that is a thicker substance. So the example that I always give is molasses or syrup. Does anyone know what molasses is? Has anyone ever seen molasses? Okay, so usually a couple of y'all have seen molasses. So molasses, if you don't know, is a very thick liquid. It is a lot thicker than syrup. Okay, so if you spill syrup or molasses on the counter, it's going to not move as quickly. You're going to have time to clean it up. Whereas if you spill water on the counter, it's probably going to go all over the counter. But because your syrup or your molasses has viscosity, or because it is a very viscous substance, it's going to take longer for that molasses or that syrup to travel across the counter. So it's going to move very slowly because it does not want to flow. It is the resistance against flowing. Okay? So fluid is something that's going to move very easily across the counter or across the surface. Viscosity is something that's going to move very slowly across the counter because those intermolecular forces are stronger and it's going to keep those things closer together than in a fluid substance. So a fluid substance is going to have weaker intermolecular bonds. Viscosity is going to have higher intermolecular bonds. Okay. So again, in liquids, if your substance is more viscous, if your substance has higher viscosity, that means that those intermolecular bonds are going to be stronger. So the stronger your intermolecular bonds, the more viscous your substance. These are still both liquids. So we're still talking about behaviors of liquids. It's just you could have stronger intermolecular bonds that are liquid but not yet a solid. Or you could have weak intermolecular bonds that are liquid, but not yet a gas. So that's the difference between fluidity and viscosity. So another example I kind of sometimes give is glycerol, but I know some of y'all don't know what glycerol is, or most of y'all probably don't know what glycerol is.
What is that, Miss?
Glycerol is an oil. It's a very thick oil that is used as a lubricant to put a glass tube inside a rubber stopper. So that's another reason why I don't like to use that example. Anyway, so viscosity is also affected by three things. So viscosity can be affected by the molecular forces, the intermolecular forces of your substance in between your molecules, the size of your molecules, and the temperature of your substance. So the intermolecular forces, the size, and the temperature. Those three things can affect how viscous or how fluid your liquid is. So if your substance has very high intermolecular forces, like I've said before, if your intermolecular forces are very strong, then it's going to be a very highly viscous substance. Also, your size. If you have a larger size particle, so if your molecules have a larger molar mass, then those forces are going to be stronger, which means your viscosity is going to be stronger. So lastly, temperature. So if you raise your hand if you keep your syrup in the fridge. Some of you do. Okay. Do you?
I thought everybody did that.
No, I don't.
Are you serious?
It's in the pantry. It's where it belongs. Anyway, so if you keep your syrup, in the fridge, do you take it immediately from the fridge and put it directly on your waffles?
Yes.
You do? Okay, how long are you sitting there waiting for that syrup to come out of that container?
Not that
I think my
long.
mom gets the really gross, healthy, liquidy stuff.
Okay, see, that's another issue. Okay,
Yeah.
so if you were talking about the good stuff, the natural syrup, if you put it in the fridge and you go to take it out immediately and put it directly on your waffles, you're going to be sitting there forever trying to get that syrup on your waffles because it is cold, and if your substance is cold, it is going to be more viscous. So usually if you go to a restaurant and you ask for something that has syrup in it, the syrup is either going to be at room temperature, or sometimes what they do, depending on who they are, is they will even warm up the syrup and make it warm so that it's easy to come out of the container so that you can quickly put it on your food. So the hotter something is, the higher the temperature, the more kinetic energy that syrup has, the less viscous it will be. The less kinetic energy, so the colder it is, the more viscous it will be. Yes. When one of those two come back. So either Leo or Louis. Either one of them. Okay? So viscosity is affected by the intermolecular forces, the particle size, and the particle temperature. Average kinetic energy, sorry. Okay. So, the next couple of things that I want to talk about are unique properties of liquid water. So, these three phases of matter that we're talking about solids, liquids, and gases, but they are of the same substance. So we're talking about solid ice, which is water, solid water, which is ice, liquid water, which is water, and then gaseous water, which is water vapor. So we're talking about water in its three forms. So what kind of unique properties does it have in its liquid form? Because if you do not know, water is a very weird substance, and it does not obey the rules that it should obey. But because it doesn't obey those rules, that is why we are literally here on this earth. Okay? So water is a very weird substance. It does not obey the laws that it should obey. One of those things being surface tension. So if you look at this picture here, I have this insect that looks like it's magically walking on water. But that is not what's happening, because that does not happen. All right. So what is happening is that this bug, we're talking about this bug, no one else, just this one bug, no other beings that may or may not have, anyway, so we're talking about this bug, and this bug is taking advantage of two things. One, the surface tension of water, and two, it's also taking advantage of the surface area of itself. Okay, so what is happening? I have this picture here. This is the picture of the water that it is sitting on. So this is the lake, okay? You have water molecules all throughout this lake. You have ones on the top, ones in the middle, and ones in the bottom, okay? The ones on top, so let's say I am a water molecule at the top of this body of water. I am not feeling any forces above me, because there's no water above me, there's only air. So I am not feeling any forces of other water molecules above me. The only place I'm feeling them are to the sides and to the bottom. So there are water molecules below me that I am feeling attractive forces from. Below me, underneath me, there are water molecules that are feeling attractive forces and that are sending out attractive forces to everything around it. Okay. So what's going to happen is that these attractive forces are going to be stronger than these ones. And so these molecules are going to pull these molecules down and kind of shrink them in and squish them in and form a protective barrier against anything on top that's trying to go through. So, has anyone seen Guardians of the Galaxy Volume 1? Okay, so when they are trying to, what's the bad guy's name? What's his name? I don't remember. Anyway, so when they're trying to protect Earth,
It's Ronan.
Ronan. Okay,
Ronan.
so when they're trying to protect Earth from Ronan, right, and they have all their ships, are you listening? They have all their ships interleaking, yes, and they form that barrier against Ronan. That is surface tension, okay? So you have all of these water molecules forming this barrier on top. These molecules are being pulled down and squeezed into or closer to these ones. So it's going to form a barrier. Now, the water bug, or whatever it is, it's going to spread out and it's going to increase its surface area, much like you do when you go to float, right? When you go to float in a pool or the ocean or wherever you're at, you spread out, right? You lean back and you spread out. You are basically doing the same thing that the bug is doing, but the bug is actually able to float on top because it's a lot smaller. It has a lot less mass. Sorry. So because it has less mass, it's able to literally float on top and not penetrate the water because the surface tension is pulling those water molecules tightly packed together and creating a barrier against the water bug. Does that make sense? Perfect. Not a force field, but like Red Rover.
Let's try it.
Red Rover.
I'm talking about like,
Anyway.
no, I'm talking about like the government. You think they can make like a force field? Like with all their knowledge?
All right, so the second thing that I want to talk about is, so another unique property of water is that it will undergo forces of cohesion and adhesion. So cohesion, what cohesion is those are the attractive forces keeping water molecules together. So your water molecules are experiencing cohesion forces. This is supposed to be attraction, by the way. That's attraction. Okay, so cohesion is keeping your water molecules together. Adhesion is keeping the water molecules close to the wall of its container. So this one is adhesion, this one is cohesion. So cohesion is keeping the water molecules together. Adhesion, your water molecules are going to adhere themselves onto the wall of their container. So what you have all throughout your body and what plants take advantage of are called capillary veins. Your capillary veins are very, very, very tiny veins. They have a very small diameter. Because if you notice this picture, so this picture, if you can see, the blue line is gradually going up as you go from left to right. That is because the diameter of these capillaries, of these capillary veins, for example, the diameter is getting smaller and smaller as you move from left to right. So this one is smaller than this one, okay? So what's going to happen is the smaller you make your container or your capillary vein, the higher the attractive forces of your adhesion are. The higher attracted your water molecule is to the side of its container, to the walls of its container. So what's going to happen is your water is going to literally crawl up the walls of the container. So that is why you water the roots of the plant down there in the ground and not the leaves of the plants that are up here looking at the sun. Because the plant's capillary veins, how they get water, goes from the roots. So water is literally able to flow against gravity and go from down in the ground all the way up to the flower plant leaves part, okay? Because of cohesion and adhesion. It is very crazy. That's crazy. So, cohesion is the water attracted to other water molecules. Adhesion is the water molecules attracted to the wall of the container. So this is also why we have to read a meniscus. So what a meniscus is if you are looking at a graduated cylinder. So if you're measuring a liquid in the lab, what you have to do is you have to get down at eye level and you have to look at the measurement that's at this part. If you look at the measure that's up here, you are going to read the wrong number. So let's say that is 42 milliliters and this is 40 milliliters. Depending on what reaction you're doing with water, that could be a very big difference. So you have to be accurate. So you have to read the meniscus.
Seniors.
Because of the adhesion and cohesion, it's going to make this part of the water start crawling up the sides of the container. But you don't want to account for that. You want to account for the level of the water, which is the lower line, which is the meniscus. Any questions about anything before you leave? Okay, so mini quizzes 1 and 2 tomorrow. We will finish the PowerPoint tomorrow. Your test is on Friday, so you need to start reviewing and you need to start studying tonight.